Start.
You can start now.
Yes, sir. I will short the session, sir.
Yeah. You start from the beginning, ma.
Okay, sir. A wonderful morning to one and all present here. Yes, sir.
Yeah. You start, ma. Karthik, sir, can we proceed, sir?
Yeah, sure.
Yeah. Start, ma. Start.
Okay, sir. A wonderful morning to one and all present here. I hope everyone is sound and safe. I warmly welcome you all on behalf of Jeppiaar Institute of Technology to the Future Tech webinar session on wireless communication essential. Feedback forms will be posted in the live chat at the end of the session. Participants are requested to fill those forms. Question and answer session will be held at the end. So I request the participants to post your questions in the chat box. For any queries, contact our organizing team. I heartily thank our beloved director, Dr. N. Murray Wilson, for supporting us, and I also thank our beloved principal, Dr. L. M. Marling Livingston, for encouraging us to organize the webinar session. I warmly welcome Mr. Karthik Tyagarajan, Senior Engineer, Apple, USA, on behalf of JPR Institute of Technology. Mr. Karthik Tyagarajan is an experienced senior engineer with a demonstrated history of working in the consumer electronics industry. He is an excellent engineer with extraordinary problem solving and analytic skills. He is well versed with LTE specs and writing test plans, defect tracking. He is excellent in automation as well. We are happy that he is joining the session from USA and the time is now 10:57 p.m. Welcome, sir. Now I request Mr. Karthik Tyagarajan to take over the session. Please, sir.
Thank you, Gauri. Thank you for the introduction. I hope everyone who's hearing the session is doing well. And I hope everybody's taking care at home, given the situation and scenario. Um, so today, I'm very excited to talk with you folks regarding the wireless communication aspects. And I believe I met all of you when I visited India, which was a really memorable trip. So I thought this will be a good extension to where we left off. And basically, I wanted to dive more into the wireless engineering aspects. And basically, these will be very useful for you to perceive or to find a job, to basically develop your skill set, to basically ramp up on your wireless skill sets. So I hope this session is of real use. And please, as I think as Gauri mentioned, please let me know if you have any questions towards the end of the session, and feel free to reach out to me offline via LinkedIn or any other social media. Okay, so let's dive into the session itself. So hopefully you can hear me good. Gauri, can you confirm that?
Yes, sir. We can hear you.
Okay, great. Okay, to start, so I have a slide basically which I thought will reflect regarding the different wireless aspects that I wanted to cover. So in this session, we will briefly go over the different wireless technologies that we use on a daily basis. So the first one being cellular, the second one is Wi-Fi and Bluetooth. So in cellular, I would basically be going over specifically about LTE. And given these three technologies, we will talk about the wireless coexistent aspects of this. So this is a very interesting topic that I wanted to discuss with you all, that basically extends beyond the singular technology. And this is a very hot topic that that is being discussed in the industry, and also this topic is going to be there forever because the wireless coexistence challenge is never going to disappear if you have multiple technologies. So we will go through the different challenges we see and the mitigations we apply and how we solve those issues. So I'll be briefly going over that. And the last two sections, basically the second last section is I will give you like some references to where you can go and find material for different concepts that I'm presenting today, so that you can read at home and learn regarding those concepts and apply it in your curriculum as well. And the last bullet is the takeaway. So what do you take away from this presentation? What is it that you benefit out of this presentation? So that's something I want to cover as well. Okay, so let's go to the wireless concepts, and the first being the cellular. So I'm not sure of the different backgrounds of the people on the call, but I hope that some of you may be familiar with LTE and cellular, and this is really the hot technology currently in India. So they're still working. Excuse me, they're still working towards the 5G and enhancement of 5G. So 5G has still not reached India, but 4G is a good starting point for everyone, and basically to ramp up on the cellular concepts. Um, so some of the key, I just wanted to highlight some of the key technical details here. So what is the spectrum access? Um, so as some of you may know, spectrum access is the different modulation technologies. It goes with different modulation technologies that you use in the cellular world. So for LTE, we have the OFDMA. I'm not sure how many of you know are familiar with this. It's orthogonal frequency division multiplexing access, and SCFDMA. So OFDMA is used for the link between the base station and the cellular, and SCFDMA is used from the link between the cellular and then the base station, right? And modulation. So I'm pretty sure many of you are aware of this term called modulation. What does this modulation mean? So modulation basically helps you achieve different bit rate and throughput. So that's what they call as data rate, right? So different customers have different data rates. So how do they achieve that? By having different modulation schemes. So as you can see in the figure on the right, I've briefly pasted the concepts for OFDMA and SCFDMA. So how does this work, right? I'm not sure how many of you are aware of this, but the first graph is Q versus I plot, which is the quadrature and amplitude plot. So I've taken QPSK as an example here. And so basically you can have 4 possible combinations of data that you transmit. So how do you transmit this data? So again, we go back to the spectrum access for OFDMA. So let's take the example of OFDMA, which is illustrated below. And as you can see in the frequency domain, there is basically a 15 kilohertz spacing between carrier. So what you do is you modulate the different data symbols and you transmit over the frequency domain. And you do this for multiple users. And that's how basically the frequency spectrum is occupied for each user. So more importantly, I think the FDD and TDD concepts are very important in cellular world. I'm pretty sure maybe some of you may have heard this as well. So what does FDD and TDD mean? So FDD is basically the frequency division duplexing, where we have different frequency configurations for the uplink and downlink transmissions, which is basically from the base station to the mobile user and the mobile user to the base station, right? That's what we call as uplink and downlink. In TDD, basically the deployment is across the same frequency, but across different time. So every user gets the own slot to transmit and receive, but the frequency of transmissions and receive is the same. So that's what TDD means. And some of the other concepts that I've written is the channel bandwidth, which we use for LTE, and the frequency of deployments. So what I want you folks to mainly focus on is basically the frequency of deployment, right? So frequency is, you can see that it's basically from 700 megahertz to 2700 megahertz. So it's a 2000 megahertz frequency deployment. So that's what it is, right? So that's basically the cellular concept that I wanted to enhance on this slide. And hopefully, if any of you have any questions, please make a note of it for the slide, and we can talk about it once I'm done with the presentation. So the next wireless technology I wanted to talk about is Wi-Fi. So Wi-Fi is there at our home. Many people are almost using Wi-Fi all the time, even more than cellular, I would say. So how does Wi-Fi work? Let's take a look. So Wi-Fi has a similar OFDM spectrum access. So for folks who want to know more about OFDM, uh, feel free to reach out to me offline, or you can also Google it. There is a ton of information online. So the idea mainly I wanted to show here is to open the different configurations and technical aspects. So I expect you folks to go and read it online. So that's what I expect of you. But don't hesitate to contact me. So again, coming back to the slide, the spectrum access is OFDMA and the modulation is QPSK. So that's interesting. In cellular, we had up to 64 QAM. If you observed, the cellular slide, we had up to 64 QAM. But in Wi-Fi, we have only until QPSK. So QPSK, so traditionally that means Wi-Fi is supporting lower rates, but the current Wi-Fi specs and standards actually allow Wi-Fi to reach higher rates, higher throughput data rates. So let's go over the different diagrams I have here, right? So the different frequency of operations for Wi-Fi is the 2.4 gigahertz and 5 gigahertz channels. So this is predominantly used across different countries, and this is the configuration which is deployed in majority of the places, right? So so I'm not sure how many of you know about this, the CSMA-CA. So this is a very important concept for Wi-Fi, right? So the difference between Wi-Fi and cellular, in cellular, you basically have the network allocate you when you transmit, when you receive, right? So the network is the boss. The device or your handset basically behaves as to how your network says. In Wi-Fi, you basically sense the medium. If your medium is busy, you don't transmit. So what I mean by that is this is what we call as a CSMA CA, carrier sense multiple access, right? So you sense the medium. If anyone is doing so, let's say I am the first user, and let's say I have two other neighbors. If any of those neighbors do a transmission, I would not do a transmission. So first we would need to get access to the medium, right? So that is what is called as the RTS and CTS, as shown in the diagram here. So RTS means it's request to send. So the transmitter basically sends a request. So I would basically send a request to send. And once the access point, basically a Wi-Fi station, right? Once it says that, hey, okay, you're clear to send, basically I will do any transmissions after that. So this is a very important concept. Please make a note of this. And also this is one of the very basic interview questions. If someone were to ask you, how does Wi-Fi work, right? For sure, someone would ask you CSMA-CA, right? And similarly in cellular, please make a note of the OFDMA, SCFDMA. And if you folks are interested to pursue in anything in wireless domain, you need to know the different modulation schemes and how it works. You need to know the math of how the mathematics works. You need to know the QI diagram, which I spoke about briefly. So you need to know that as well. So these are very key wireless concepts that I've cherry picked. This is not all of it, but this is very, very key. You need to know these concepts. And also FDD and TDD, of course, that's like a very basic thing. All right, so moving on to slide number 4. So Bluetooth. So when we talk about wireless technologies, we have cellular, we have Wi-Fi, or we have Bluetooth, right? So Bluetooth is a very interesting technology as well. And the key difference for Bluetooth is it uses something called as adaptive frequency hopping. I'm not sure how many folks have heard of that. What does that mean? What does adaptive frequency hopping mean, right? So if you see the diagram on the right, so you can see the rectangles highlighted in red are actually the BT transmissions. So these BT transmissions can happen in different frequencies, okay? So each of these red rectangle is positioned differently if you observe in terms of the height. So the height, the y-axis is basically the frequency, and the x-axis is the time, right? So Bluetooth transmissions and receptions can occur at different frequencies at different time. This is very important again. So this is not the case in Wi-Fi, or this is not the case in cellular, right? Let's go back. Let's go back and check. So in cellular, if you see in the FDD and TDD diagrams, its time is always, so the frequency is always fixed for a specific transmission, either uplink or downlink, the frequency is fixed. And similarly, if you see in TDD, the frequency is fixed, right? And similarly in Wi-Fi, there is no ambiguity, right? In Wi-Fi, if you see this 2.4 gigahertz or 5 gigahertz, it's always set, right? You always transmit in the same frequency. But in Bluetooth, it's very interesting. So this is actually why is this the case for Bluetooth, right? Why is it not the same as cellular or Wi-Fi? So that's a very good question. So adaptive frequency hopping in a way kind of encapsulates it's also a security, right? If someone is trying to snoop, say your AirPods or your headset, or say any BT accessory, Bluetooth accessory, they could not do it so easily, right? It keeps hopping every instant of time. So this is an implicit security that Bluetooth has in place. And also the actual transmissions can happen based on which frequency is good to actually transmit or receive. So that's a very key concept that you guys should know. So what I mean by that, let's say that the first transmission is not good, right, in a specific frequency. And say you keep hopping these packets in different frequencies. So your probability of getting the packets through in a different frequency is higher than the worst frequencies, right? So in a way, you're actually improving the transmissions. In a way, you're improving the probability of transmissions. So that's why BT is using adaptive frequency hopping, right? So some of the key technical details that I've listed here is again, the same, it's a apple-to-apple comparison for cellular, Wi-Fi, and Bluetooth. You have the spectrum access, you have modulation. So Bluetooth doesn't require QPSK or QAM, right? Bluetooth is very low throughput, right? It's just a very low throughput operation. Bluetooth, of course, has a very strict requirement on jitter and latency, right? So for example, if I'm talking something on my AirPods, and say if the jitter and latency are not as good as it's supposed to be, then you would lose packets. You would not be able to hear me, right? So that's the key metric for Bluetooth. But for modulation, you don't need a high throughput transmission or a high data rate transmission. And the channel bandwidth. So again, this is a little bit of a technical detail. There is something called as BT Classic and BT LE, right? So BT Classic, what is BT Classic? So BT Classic is any device that you use, like your headphone, AirPods, or you listen to some music in your car. All of this comes under the BT Classic category, right? What is BT LE? BT LE stands for BT Bluetooth Low Energy, right? So BT LE is used only for areas where you need a low energy, low latency of transmission and everything. So it basically means that it is used, for example, in medical devices, or basically say when someone is using their apparatus for hearing aid. So all these devices use BT LE. They don't use BT Classic. Why is that? Because the frequency of operation for those devices may not be as high as BT Classic. So they may not need a strict and requirements for basically to listening for music. So music is like almost every millisecond, right? So you need a very strict requirement to meet those standards. For BT LE, it can be low power. You just need them to operate at certain times where you save the battery, you save the power, right? So that's what is called Bluetooth Low Energy. So some technical details, again, you folks, please feel free to reach out to me or Google it. The BT Classic has a 1 megahertz channel implementation, and we have 79 channels. So again, if you see on the figure on the right, it starts from 2402 to 2480, right? And if you see 1 megahertz, it's 79 channels, right? You have 79 channels in total. For BTLE, this bandwidth is a little bit higher. It's 2 megahertz, right? So again, all of these questions are very basic for an interview. Uh, say if someone asks you questions about Bluetooth, uh, for sure they're going to ask you adaptive frequency hopping. For sure, you need to know the channels of operation, again, the modulation. So anyone who's interested in these areas, please ramp up your skills on all of these topics. And the last bullet, I have the different profiles used for BT, right, on Bluetooth. So what does profiles mean? So profiles is basically an implementation in the Bluetooth standard, uh, each actually allowing a different use case. So we have different profiles like A2DP. So A2DP means it's, say, for your audio, you're hearing music, right? That's an A2DP. HFP is a hands-free profile. So basically, say you're taking a call uh, in your car, right? You just take it via Bluetooth. So basically, HFP is what is used. LE, I think we spoke about it. You have the low energy audio. So you have the hearing aids, you have all the low energy devices. And eSCO is also for calls. So uh, please Google these areas, each of these key concepts, and please read into it what it means. I know it's probably too many things at one time, but once you start reading on it, it will make sense. And I think it'll make more and more sense. But again, you need to be good in connecting the dots. You need to be good in um, linking the dots, right? Knowing how to connect the dots. So please do that. Um, and let's go to the next slide. All right. So this is something I prepared for you folks because I feel that this area is really picking up, and it is an area of um, interest, or rather, it is an area that's never going to die. It's an area that maybe all you folks should be interested. And trust me, if you're good in this area, um, you can definitely make it, in one of the top companies. So please read. I'll go through those points, but please try to also Google it and see what each of these means. So wireless coexistence. So what does this mean? So we spoke about cellular, we spoke about Wi-Fi, we spoke about Bluetooth, right? So now for an end device, all of these signals um, can come together at the same time, right? So you can be camped on a cellular, you can have a Wi-Fi signal, you also have your Bluetooth. So how does it impact the signals? Say, for example, how does the signal of cellular impact Wi-Fi, right? How does the signal of cellular impact Bluetooth? So, and the question is, why is this even a problem? Someone needs to ask that question, and that's a very good question. Why is this even a problem? So let's go back to the slides. Okay, so if you see the cellular, I went through the frequency. Of course, we didn't go through each frequency, but if you see the frequency, there is an overlap with cellular, Wi-Fi, and Bluetooth, right? If you see Wi-Fi, there is a 2.4 gigahertz operation. In cellular, also there is 1700 to 2100 and 2500 to 2700, right? So if you see these two frequencies, they're very close to each other, right? And similarly in Bluetooth. In Bluetooth, it's also in 2.4 gigahertz. So basically the idea is cellular, Wi-Fi, Bluetooth. All these three signals are going to interfere, right? Now, these are very common technologies that we use. There are several other wireless technologies which can be incorporated and which may come up in the future, right? Each of these technologies will have a challenge of deployment uh, with each other, right? So that's what we call as coexistence, wireless coexistence. So this is a huge challenge. Um, of course, each company has its own solution of how they solve it, and this is going to be forever, right? So let's go through the challenges. So the challenges we have is the RF or spectrum sharing. So briefly, we just spoke about the frequencies, the frequency deployments. So that means that in itself means RF or spectrum, right? So Wi-Fi has a spectrum, Bluetooth has a spectrum, cellular has a spectrum. When all of these interfere, what kind of problems do we have? The first one is out of band. The second one is blocker. So these terms, I will just go through it. Maybe we won't go very detailed, but please again Google all of these individual concepts. It's very interesting. So and of course reach out to me if any questions. So out of band, blocker, intermodulation, distortion, and harmonics, right? All of these are a problem. It's so let's take for example the case of harmonics. What does harmonics mean? So so the harmonics is the definition where an nth frequency will interfere basically the third harmonic or second harmonic of some other technology. Say, what do I mean by that? Say if we have a deployment for cellular at 700 megahertz, right? What is the third harmonic of 700 megahertz? So it's 700 multiplied by 3, right? So that's 2100 megahertz or 2.1 gigahertz. So if we have a deployment of cellular in 700 megahertz, the third harmonic is going to interfere with your Wi-Fi or Bluetooth. So Wi-Fi and Bluetooth both operate in 2.4 gigahertz, right? So 2.1 gigahertz is very close to 2.4. So this introduces a coexistence challenge, right? So how do we actually, so what kind of, okay, to finish the concept, what kind of challenges are there? So we call them the in-device coexistence. So TX energy sharing. So when you basically transmit on a specific technology in an antenna, you're basically transmitting at very close frequencies for different technologies, right? So this creates a TX energy sharing, right? Antenna sharing. Now, generally, the antenna design for different technologies. So it's very simple, right? You would potentially use the same antenna to transmit that frequency, even if it's different technologies, right? So, um, so coming back, so if you have like the same antenna transmitting for different technologies, how is that going to work? Because say the transmissions may be very close to each other, right? For different technologies, you may be transmitting with the same antenna very close to each other. How are you going to mitigate that? That's the problem in antenna sharing, right? And the last one is the clock sharing. So the clock, what does clock mean? So the clock is the frequency. So I'm pretty sure everyone has probably heard about the oscillator, the crystal oscillator. I'm talking about the hardcore DSP, the wireless engineering people, students. You should have heard about this concept, the crystal oscillator, the feedback oscillator, and things like that. So the clock is very closely related to these concepts, right? What is the frequency at which you're clocking, right? And this frequency of clocking changes for different technologies, right? So this is also a challenge. So how do you mitigate this? So these are the different kinds of questions that we need to address when we have the topic of coexistence in our, in our window. So again, please read about all of these things Google and reach out to me for any questions. Let's go to the next slide. All right. So here I've actually illustrated an example um, of a coexistence problem, right? So let's go to the figure, right? So if you see the purple and the orange ones highlighted on the right, so they both are cellular signals, right? So both are cellular, and if you see, it's very close with Wi-Fi and BT transmissions, right? So both Wi-Fi and BT are very close with each other. So what do I mean by that? So I've given you a sample frequency of deployment for cellular. So let's assume that 2350 megahertz and 2385 megahertz is the deployment for cellular. These two are the carriers. They're very close with the Wi-Fi channel 1 and 2, the lower end of Wi-Fi, and the 2510, if the orange figure on the right, is very close to the Wi-Fi channel 1213 and BT upper end of the BT, right? So this is how the interference is caused for coexistence, right? So this is purely a beautiful example of coexistence. So how do we mitigate this? We can have two sorts of mitigation, right? So again, as I mentioned, all of this is each company does their own thing, own magic, they solve their own ways. The question is, as an engineer, how do you bring the solution to the table, right? So that is what makes you unique, right? So that's what you need to focus on. So the mitigation can come from either hardware or software, right? Even either the hardware can mitigate the coax issues. You can fix the hardware. Say you have good filters, you have good design of all the filters, you can mitigate it. Or software. Software should be basically a solution or a code which mitigates very intelligently. It basically avoids the victim scenarios, right? So how do you avoid this victim scenario is the question, right? So these are the sorts of problems that we face in the industry, and this is something I wanted to show you folks, because I know that many people just talk about cellular or just Wi-Fi or just Bluetooth, but the grander picture is coexistence, right? If you're able to solve these coexistence issues, you can go as a system design engineer, you can go as an architect. Um, so you can solve several problems, right? So that's the idea here. So this is the concept I wanted to show about the coexistence. So the next slide. So in the next slide, I've given you the references, right? So what next, right? So that's the bigger question for me. What next? After showing you all these slides, what do you do next? So what I would recommend each of you is to go to each of these standards, right? Uh, Whether it's cellular, whether it's Wi-Fi or Bluetooth. So I've given the link to each of these standards, uh, who actually govern of how these technologies should behave. And there are tons of documents in this website. So please go here and please read. It is a little bit tough to start because you need to know how to start it. If you are really struggling to do that, please reach out to me, and I can always help you on with how to start reading the specifications, and how to learn the concepts and how to take it forward. If you're if you know how these standards work, I can guarantee you that you will definitely be an expert in wireless engineering, right? That's the key goal. And so I want each of you to go and research on what each of the standards mean, and look at these websites, and please get back to me. I'll just give a brief overview. So 3GPP is basically the standard. So I'm starting from the cellular standards. The 3GPP uh, is the one which is currently driving LTE, 5G, even earlier technologies like WCDMA, GSM, right? 3GPP2 is basically the CDMA technology. So if you guys know, like, uh, 3GPP2 is kind of, it did not win the race. 3GPP won the race. So since 3GPP won the race, that's why they're governing the standards for 4G, 5G, and so forth, right? So it's clearly 3GPP is the winner. So what I would advise you folks is read 3GPP. Don't pay too much attention for 3GPP2 as of yet. And for Wi-Fi standards and Bluetooth standards, it's very simple. Wi-Fi is Wi-Fi Alliance, and Bluetooth is Bluetooth SIG, right? So these are the groups. Um, Again, please feel free to reach out to me for any questions. So let's go to the next slide. So what do I take away, right? Um, this is the grand question which I want to answer for each student on this call, right? If you are interested in wireless engineering, please ramp up on these wireless fundamentals that I spoke about in cellular, Wi-Fi, and Bluetooth, right? Read through the specifications mentioned in the previous slide, of course, as I mentioned. The most important, please brainstorm all the concepts you read with your friends, professors in our college. Please go and talk with people in the industry. You can talk even with me. please feel free to do that, because at the end of the day, you cannot read everything, right? You have to talk with people, you have to learn from other people, uh, and who they may learn something from you as well, but that's how it is, right? So please do this. Should I pursue with wireless coexistence? And the answer is 100% yes. As I mentioned, coexistence is going to be there forever. It is always viewed as a terrific challenge, right? And as I mentioned again, several wireless companies are looking at this, right? So please pay attention to that, right? So these are the key takeaways that I had, but we can discuss anything that as a question if you have, as a follow-on, right? So the next slide. So this is the pretty much the last slide. So which companies? So this is a question I've been hearing from several people, right? Uh, which companies do I apply, right? Hey, where do I start? How do I look for jobs? So this is the question I get, right? So to help you folks, I have actually categorized, at least in the wireless domain, on how you can chase your dreams and get a job, right? So this is how, to be honest, this is how I got my first job, right? This is how I viewed myself. This is how um, I started my career. So the first set of companies is a chipset development, right? So these are the key players, key chipset players, right? So Qualcomm, Broadcom, Intel, and MediaTek. So I worked in Qualcomm, for a brief amount of time, and I would encourage all of you folks to. So let me give you a brief overview of what they do. So Qualcomm is is predominantly the front runner for the chipset company in terms of development, in terms of like outsourcing it to different companies, right? So Qualcomm is a front runner for cellular chip for cellular, for Wi-Fi, for cellular and Wi-Fi, right? Broadcom. So Broadcom is a front runner for Wi-Fi and Bluetooth, right? So if you want to search for jobs regarding Wi-Fi or Bluetooth, Broadcom is a good place as well. Intel. So Intel, I don't know how many of you know, but Intel got recently sold to Apple. So the cellular organization in Intel is no longer valid, but Intel does again Wi-Fi chips, right? And MediaTek is again a cellular competitor to Qualcomm. Um, so the key takeaway here in the chipset development column is how do you approach your career, right? In so again, it's left to the individual, right? If you like a specific domain or if you like a specific area, say if someone likes only Wi-Fi, they want to be an expert in Wi-Fi, right? So Qualcomm and Broadcom are your companies, right? So that's the idea I have. So you should pick which area you like. It's okay to know everything. Like you can learn everything over time. You can learn everything, but keep a realistic goal. Keep Let's start with one thing, right? Let's learn things around it, right? And then let's go to multiple technologies, right? So that's the strategy I will give you as an advice. Don't jump on everything at once, because you lose focus, and it becomes hard, right? Okay, so let's go to the second column. So in second column, you have Apple. So Apple is where I work. I used to also work for Samsung back in 2010. So LG is one of the companies. You have also Xiaomi in India. So all of these companies are the product development companies, right? So say if you're good in wireless standards, say if you know wireless technologies well, now you want to say focus on a product development. So basically, you want to take whatever knowledge you have in chipset, I'm sorry, excuse me, whatever knowledge you have in wireless area technology to a product development. So this is where the integration happens. So quite honestly, in product development companies is where you will learn several technologies, right? Because the chipset development companies, you just learn a specific technology, like because they're just focused on either Wi-Fi, cellular, or Bluetooth, right? product development is where you learn everything, all like cellular, Wi-Fi, and Bluetooth, because a given product needs all these technologies, right? So, so I would say start with the chipset development initially, but if you're interested in product development, you should always target that as well, right? So the third set of companies are the network operators, right? So Ericsson and Alcatel-Lucent. So Ericsson is a no-brainer, and Alcatel-Lucent too. These are the two major network vendors who are provisioning 4G, who are provisioning 5G, who are provisioning 3G. So these are the guys. So what kind of skill sets do you need here? It's very similar to chipset development, right? So if you're aware of the specs that I listed and the wireless technologies that I listed, you can definitely either jump into the chipset development or network operators, right? And carrier operators. So carrier operators um, requires a little much more dense knowledge. So you need to keep reading a lot about spectrum allocation. So so you need to understand the key concepts of spectrum allocation, for example, and build on it. I just came up with some of the carrier operators which are there in India, but this is just to give you an idea, right? So I may have missed some carrier operators, but this is the way to approach your career. So the idea here is please pay attention to which area you want to focus. My recommendation is start with just one thing, and if that pans out well, then jump into the several other technologies and move on, right? And please keep that in mind. And yeah, so that's all I had for today's presentation. And good luck to you folks. I think I can take any question and answers now, if any. Like,
Yeah, Gauri Puja, you can go ahead with
Yes,
the
sir.
question and answer
Yes,
session.
sir. Thank you, sir. It was a very informative and interesting session. There are many questions, and I would like to pose some of them. The first question is from Malai Satya. What is CCK?
right. So CCK is one of the modulation technologies that is used basically in Wi-Fi. So CCK is a low key concept technology. So again, this is something that I don't want to emphasize and explain a lot, but please Google it. It is one of the key concepts in Wi-Fi. Yeah, so maybe we can go to the next question. I think it's pretty
Thank you.
self-explanatory. Yeah.
Yes. And from Devapriya, what speed LTE offers and what is the goal of LTE?
Okay, that's actually an excellent question. Um, so again, LTE has several concepts, right? So in regards to, so the first question was the data rate, Gauri, is that right?
Yes, sir. Yes, sir.
Okay, so
What
in
is the
regards
speed?
to that, right? So in regards to that, there is a principle called carrier aggregation, right? So if you see the channel bandwidth that I've listed here, 20 megahertz is the highest, right? So for 20 megahertz, you can get a speed of 150 Mbps, right? But carrier aggregation is a concept where you can have several of these carriers, basically, that can achieve 150 Mbps each. So say if you have 5 carriers, right? You can get a speed of 750 Mbps, right? But of course, no one is going to use 750 Mbps. That's not even realistic, right? The goal of all these technologies, especially LTE, right, is basically something called as a channel capacity. So I think if you folks are really interested, I can organize one more session where I go through the key details, right? But to actually give on a highlight basis, the channel capacity is the number of users you have active at a given time, right? Because of these high data rates, the base station, or we call it the E node B in LTE. So the E node B is capable of supporting several users at the same time, right? So say for example, we had 3G, right? So the 3G's channel capacity will be much lesser than LTE, right? So that way LTE helps achieve more users at a given time. So hopefully I answered your question, but reach out to me offline if you have more questions regarding that.
Thank you, sir. And there is another question. What is the major education for product development companies by Kartiga Kannan?
What is the major
Education,
education?
qualification for product development
Yeah,
companies.
so that's a good question. So the product development companies, see, the idea is they want people um, who are at least well versed with one or two sets of skills. So, say for example, you're good at Wi-Fi and cellular, or Bluetooth and cellular, um, or Wi-Fi and Bluetooth, right? So, product development is something where they want a system level knowledge, right? So they want to use you uh, basically to analyze different subsystems, for example. To give a very high example, so I work at Apple. So what we look at is basically um, how good are you in a given area that is always there in any company, but also what is that you bring in extra along with your just that given area, right? Because the way to be filtered out is like we have a lot of people who are very good at cellular, who are very good at Wi-Fi, or who are very good at Bluetooth, right? But we want people more on the system level. So what I mean by system level, multi-technology, right? You know, Wi-Fi, Bluetooth, cellular. So you know a little bit of scripting, you know, coding. You're good at MATLAB. You're good. So we look at all these different varieties, right, of how you can bring in and integrate these skill sets in a product. So yeah, so that's what we look at.
Thank you, sir. And here's the other question. What are
Yeah,
the LTE protocols and specification by Devapriya?
that's a very good question. Actually, I think Devapriya probably knows what she's talking about. Um, So there are tons of protocols, Devapriya, to answer your question. I would it will be great if you can connect with me. I think it's a lot of things to go over on the call, but I'll be more than happy to help you out offline. So please reach out on LinkedIn and I can connect with you.
Thank you, sir. And here is the next question. Many countries are doing research in 5G, 6G, 7G, etc. And what is the necessary for that research? By
Okay,
Charmati.
okay. So Charmati, that's a great question. So the idea is basically to okay. So we want to have technologies that are time sensitive, right? So say for example, um, say if I live in Chennai, right? If I want to do, say if I'm a doctor in Chennai, right? And I want to do an operation for a patient remotely in, say in Trichy, right? Just an example, hypothetical example. We want to be able to create applications which are so time sensitive that a doctor from Chennai can do that operation on a patient in Trichy, right? So how do you achieve these kind of real use cases? Either by an increased a technology that supports an increased latency requirements. So for example, if I move my hand or if I'm going to operate on the patient, the the robo or the apparatus that's operating in Trichy should actually do the same thing at the exact millisecond, right? So we want to create technologies which are really that time critical and that time sensitive. And also, like as you know, like we want to create like different technologies, like say 5G, right? 5G focuses on something called as a millimeter wave, right? So what does millimeter wave mean? Millimeter wave is a short range communication, which actually has a very high throughput, and it uses like concepts like something called as beamforming. Um, so again, these terms like are maybe new to you, but please Google them. Like beamforming is a very critical operation, and all of these millimeter wave operations are in a very high frequency. So that means those frequency range are unused, right? So we also want to use the spectrum completely, right? So for example, if you take the low frequencies and the mid frequency are already used by 4G, 3G, and all these areas. But so we want to deploy several technologies in high frequency range and very high frequency range. and achieve these latency critical operations. So that's why we are working on 5G, 6G, and maybe 7G in the future.
Thank you, sir. And what is the impact in wireless communication for augmented reality, virtual reality, IoT, and smart cities? Smart cities by Mr. Tandya Prabhu.
Wow, that's a very broad question. I think I think I need probably an entire seminar for that. But yeah, so how to put it across? So let's take the example of IoT, right? So when you have the backend or network capabilities increasing and exponentiating, right? You need a wireless backhaul or a wireless front end. I'm sorry, wireless front end that's equally capable of supporting this backhaul, right? So how does this impact, right? So say for operations and end-to-end operation for a user, actually it matters from the wireless spectrum to the backhaul, right? So that's where wireless actually comes into play to actually mitigate to mitigate the end-to-end latency requirements. And wireless is actually much needed, right? Um, so again, wireless, when it comes to wireless, it's all that we have discussed, right? It's 5G or 4G. So 5G, as I discussed, I think it ties into the question of, um, the earlier question that 5G has millimeter wave and all these frequency ranges and technologies that enhances the IoT operation, right? So it's all an interplay of technologies, and yeah, so that's how it is basically. But that's a good question. I mean, please feel free to connect with me offline, and maybe we can discuss more.
Thank you, sir. And here is the last question, I think. What is the frequency they are going to use for 5G communication, especially in India?
So for 5G, basically, the frequency range. So there are two frequency ranges. One is called as the FR1, frequency range one, which is the sub-6 operation. It's called sub-6. So basically, it's sub-6 gigahertz. Um, did I get some message saying there's some noise? Can you guys hear me?
No, sir. There is no noise, I think.
Oh, I'm sorry. Okay, my bad. Okay, so the sub-6 gigahertz is basically the frequency range one. That's FR1. Uh, the millimeter wave, basically that I explained to you guys. So that's the very high frequency range, right? So that's in the very high frequency and high frequency range. So that's a wave. So that's like 50 gigahertz deployment. So in India, I think initially we will start with the sub-6 gigahertz operation, which is called the frequency range one. The millimeter wave is a little bit challenging to deploy. I think that will take some time. So to start off with, it will be sub-6 to answer your question, which is 6 gigahertz and lesser, basically. Again, if you see 6 gigahertz is close to Wi-Fi, 5 gigahertz. So again, coexistence is going to come into play. So coexistence is going to be that throughout, right? Like any area with which any country, um, with the interplay of different technologies, it's always going to be there. So that's why I wanted to highlight that as a key area today.
Thank you, sir. Which noise distribution influences more the 5G systems?
I'm sorry, your voice is breaking. Can you say it again?
Now you can hear me now, sir.
Yeah.
Which noise distribution influences more the 5G systems?
So if I understand the question right, is the question like which noise system influences 5G more?
Yes, sir.
Okay. So I am not really sure about the question itself, but the noise can be caused because of different, uh, like you have the multi-path propagation, you have different kinds of propagation delays due to which the noise can come into play. Um, but you have the different channel propagation models as well. And you have like Rayleigh fading, you have different kinds of propagation models. So these are the standard propagation models. It depends on the users conditions. So say for example, noise, what is noise? So we have something called as a signal to noise ratio, right? Um, if the noise is higher than the signal, then you have a poor quality of service. So why can that happen? That can happen because of n number of reasons. There is not a specific cause. It can be because so there are some key metrics like RSRP, RSRQ. Again, these are very specific terms to LTE, so you would please Google it. So what this measures is the signal strength on the receiver. So the noise can be directly proportional with this with the signal strength. So if your signal strength is weaker, your noise can be weaker, but it's not necessary. So there can be several other reasons as well, but we can maybe cover that in another topic. Like I'm more than happy to present one more to go over maybe LT concepts.
Thank you, sir. And shall we go with some of the questions, sir?
Oh yeah, please, yeah, go ahead.
And from Pankaj Kumar Gupta, how much chances were that network interference became much often as our frequency band is increasing day by day?
I'm sorry, could you repeat that question? How
Yes,
much?
sir. How much chances were there that network interference became much often as our frequency band is increasing day by day? How much network
Okay,
interference will be there?
so right, so the so basically, if I understand your question, you're asking so as and when we deploy more and more frequencies, what is the probability of interference, right? So it is of course going to be crazy because um, as I said, like it's not just like one of the systems. It is basically many technologies that could interfere with each other, right? Uh, Given the advent of 5G, now we have sub-6 and millimeter wave. If you see, we have clean swept most of the frequencies, right? So there are really not much frequencies which are free. So these can actually interfere with your already deployed 4G or 3G systems, or this can interfere with themselves, like the 5G systems that are getting deployed, or it can interfere with Wi-Fi, which is already deployed as well in 5 gigahertz. Um, so yeah, and Bluetooth is also uh, going to be deployed for 5 gigahertz. That's not there in my slides, but that is something that the specification people are talking about. So if you see, the probability of interference is going to be exponential, right? It's never going to stop. Um, and coexistence is never going to stop either. So you have to mitigate all of these issues through coexistence, right? Yeah, so I hope that answers your question.
Yes, sir, definitely. And thank you, sir. There are many questions. Other questions will be mailed to you. And thank
Okay,
you, sir, for joining with us. The
no
participants are
problem.
requested to fill the feedback form, and so the e-certificate will be sent to your mail within a couple of days. For more updates of webinar, please subscribe to my YouTube channel and follow us on social medias. Thank you.
Thank you, sir.
Thank you all.
And
Over.
thank you, Karthik, sir. And I would like to thank on behalf of Jeppiaar Institute for your time and for your effort you have extended in spite of your busy schedule. Now, even though the time is 10:30, you spared for us and you explained very clearly to our audience. And I could able to witness in the live chats that the session was much more excellent and a lot of positive comments are being floating in and questions are also huge. That means that the explanation what you have given to the audience is much with more clarity. So thanks for that. Thanks from our end. And one more suggestion from the audience, sir. So they have
Yeah,
been asking for PPTs to share with them. If you could share the uneditable PPT of the content, we will share with the
sure.
audience through during the certificate distribution, sir.
Absolutely. I'll be more than happy to share the content.
Yeah.
And also like one request is, could you kindly send me all the questions though, like even if they are not like, uh, I can try to address it with the individual participants and
Yeah, sure, sir, sure, sir. We will just
okay,
send you with the questions. Even from the feedback
okay,
form, we will witness a lot of questions, and even we will make sure that the feedback form will also reach you. Let us be
okay,
very transparent. You can even get the feedback of the entire session from the participants as well.
okay. That's great. That's great.
Yeah,
I hope it
and
was
really it was
I
a
hope it
great
was
session, sir.
fruitful. Yeah, I hope it was really fruitful and one request to all the students is, of course, I'll share the slides, but please look into it and reach out to me if you have any questions, say further down the line, apart from the questions that you have already submitted.
And we are happy to say that Karthik sir is also alumni of us, and he's senior to me. And he's down the line. He has been helping our students with a lot of possibilities. When he reached to India, also he reached to our college and he taken the sessions, and it's quite interesting. That's the reason we called him back again for the session. So thank you,
Oh,
sir.
of
Thanks
course,
for
of
your
course.
time, and thanks for
My
spreading
pleasure.
the positivity during this time. Thank you, sir. Thank you.
No worries, sir. No worries. It's my pleasure. Thank you all.
Thank you.
Thank you,
So
sir.
much. Thank you so much.
Thank you. Thank you. All right.